Hello everyone, welcome to another non-cloud related chapter, and this is a very important one if you are working as a data engineer. And the reason is that you can use the concept of data modeling in big data technologies, data warehouses and OLTP databases also. So as you already know, this is basically a topic on data modeling, and this is going to be the agenda. I'll talk about what is data modeling and then various terminologies of data modeling, how the process is executed, then some concepts like normalization, first normal form, second normal form, third normal form, then relationships like one to one, one to many, etc. I'll also talk about denormalization. Then there would be a separate section on data modeling techniques like diagram and dimensional modeling. And in dimensional modeling, I'll be talking about facts, grains, dimensions, Snowflake schema, slowly changing dimension, etc. There won't be any hands-on as such because this is a concept heavy or theory heavy topic. So the first question is, what is data modeling? And data modeling is a technique or a way to define and structure the data in such a way that it can cater to the business requirements of the organization. Now, let's say you have fair amount of data that you get from various applications. Now, how do you want to store that data? How do you want to structure that data? When I mean by storing that data and structuring that data, definitely it has to be in a data store. So it can be relational databases, non-relational databases, data warehouses, or lake houses or data lakes, does not matter. Data modeling applies to each and every place. And the fundamental purpose of data modeling is to define the structure as per the business requirement of the organization. You just cannot go and create a structure just the way you want. It has to be specific to the workload or the business requirement that you are trying to solve. So that is what data modeling is. And this is a very important aspect of data for data engineers, because as a data engineer, you might have to do data modeling also. And if you are a DBA, definitely you do data modeling, but data scientists and data analysts do not do data modeling at all. So this is mainly a database administrator or database developer or data engineer's job. Another definition is that data modeling is the way to tell databases how to store data in tables as per a predefined schema. By now you already know what a schema is. Schema is the outcome of the data modeling process. When you do data modeling, the output should be the schema of one or more tables. So this is the way to tell databases that this is how I'm going to store data as per this schema, which is the output of the data modeling process. And it helps identify business entities as one or more tables. So what are the different business entities that are involved in the process in the IT dimension? So what you do is that you define those business entities as tables in data modeling. And it also helps define the relationships among the tables in databases. As it defines relationship, it mainly caters to relational databases because NoSQL databases do not have relations. But we do data modeling for NoSQL databases also. Now, when you talk about modeling for databases, we are talking about relational databases and NoSQL databases, or RDBMS and NoSQL. NoSQL is also known as non-relational databases. And data modeling applies to both of them. So when I talk about relational databases, what are those relational databases? For example, we have OLTP databases or online transaction processing databases like MySQL, PostgreSQL, Oracle, IBM DB2, Microsoft SQL Server, etc. So these are mainly used for operational purposes. And then we have OLAP databases also, or data warehousing systems like Redshift, BigQuery, Teradata, maybe Hive, Azure Synapse, etc. When you do data modeling, we do data modeling for OLTP and OLAP databases also. And when you talk about NoSQL, so basically there are various NoSQL databases like DynamoDB, MongoDB, Cassandra, GCP Bigtable. There's in-memory Redis, Couchbase, Neptune, which is a graph database, Neo4j, which is another graph database. So a question comes, do all databases need modeling to store data? The answer is definitely yes. Irrespective of the nature of the databases, whether it is relational or non-relational, data modeling is needed for both type of databases. In relational, we have OLTP and OLAP, so transactional and analytical or data warehouse. We use different modeling techniques for OLTP and data warehousing systems. And when we talk about non-relational databases or NoSQL databases, each NoSQL database has their own way of doing data modeling. So DynamoDB has its own way of doing data modeling. MongoDB is a little different. It means that data modeling in MongoDB is very much different than data modeling in DynamoDB. Cassandra and Bigtable follows the same data modeling technique as that of DynamoDB, more or less. Then Redis, which is an in-memory database, it is completely different than other NoSQL databases like DynamoDB, MongoDB, etc. So definitely we need data modeling for all different type of databases. One more thing that I want to call out here is that when I do data modeling for transactional or OLTP databases, the same data model would work for any of the OLTP databases. Like if you define a model, you can implement that model in any of these databases like MySQL, Postgres, Oracle, DB2, SQL Server, etc. The implementation can be done using all the databases, the same data model. Same is true with data warehousing systems also. So the data modeling technique that we define and the data model that we create can be implemented using any one of the databases like Redshift, BigQuery, Teradata, Synapse, etc. The same model can be implemented on these different databases. But that is not the case for NoSQL databases, because in case of NoSQL databases, the models are different for different databases. In this particular chapter, I'm going to talk about data modeling for relational databases only, which would cater to OLTP and OLAP both. So I'll talk about modeling techniques for transactional databases and data warehousing databases. Now, what is OLTP and OLAP? So you might already know the difference between OLTP and OLAP, but let's do a refresh. What are the various differences between OLTP and OLAP databases? So we have OLTP, online transactional processing, and online analytical processing. The first thing is that in OLTP databases, the data is born in that database, meaning that the applications that we use, all those applications write data to OLTP databases only. It can be NoSQL OLTP databases and it can be relational OLTP databases also. But data is essentially written there and data is eventually born in the OLTP databases. But in case of OLAP databases or data warehousing systems, the analysis of data is done in these databases. So data is moved from OLTP to OLAP databases and then the analysis is done there. OLTP is used to run business, but OLAP data stores are used to grow business because applications write data in OLTP and we use OLAP to analyze the data so that we can grow our business. It contains operational data and OLAP contains historical data to analyze the data. Again, the point that historical data actually ties back to the first difference where it says that data is analyzed here. We need historical data to do data analysis. So that's why OLAP or data warehousing systems contain historical data. OLTP data stores are used for both writes and reads. Some workloads can have higher write percentage. For example, let's say some workloads can have 60% writes and 40% reads, or 70% writes and 30% reads. But in most of the cases, OLTP databases might contain 40% writes and 60% reads, or 50-50. But definitely the amount of writes would be substantial in OLTP databases. But in case of OLAP, it is mostly used for reads because data is analyzed here. And when I say mostly, it can be more than 95%. So the number of writes are very, very less. And if you have a lot of writes, then maybe you should not use OLAP. The purpose of OLAP is not to handle writes. If you have a lot of writes, maybe you can batch them and then put them in OLAP data stores. And OLTP deals with smaller result sets. What I mean by that, let's say you select statement, update statement, or delete statement. The result set of those SQL statements would be very small, meaning that you would not have more than hundreds of rows. either tens of rows to hundreds of rows. So if you run a select statement, it should not fetch more than a few hundred rows. Maybe thousands of rows sometimes, but definitely not most of the times. But typically, OLTP systems deal with very small result set within single digit rows. So let's say you are updating only two rows or one row or maybe 3 or 4 rows. Same is the case with delete and select also. Insert is a little different because insert can be used to insert a lot of data. But OLAP is very different. It deals with large data sets or large result sets where it can have tens of thousands to hundreds of thousands of rows. So you can see the clear demarcation here. Depending on the result set, you can actually say whether you should use an OLTP data store or an OLAP data store. If your result set size is pretty big, then you should incline towards OLAP, not OLTP. But as I said, there can be scenarios wherein OLTP systems also return very large result set, maybe thousands of rows. But that is again very rare. And because the result sets are smaller, OLTP data stores can handle high concurrency. When I say concurrency, the concurrency can be from queries or users or connections, meaning that OLTP data stores can run hundreds of queries or thousands of queries per second, or it can handle thousands of users running queries on the data store per second. Same is the case with connections, maybe thousands of connections to the databases per second. But OLAP is definitely on the other side. The concurrency level is very low. Hundreds of concurrent users or queries are considered to be very high in OLAP data stores also. So OLAP systems should not handle very high concurrency. I mean, there are ways, the technologies that we talk about, for example, BigQuery, Redshift, Snowflake, etc., they can handle high concurrency also today. But typically that is not the case. OLAP systems should not have high concurrency continuously. Another very important pointer is the data size. And in OLTP, the data size varies from hundreds of GBs to a few terabytes. It should not be double digit terabytes. What I think is that maybe 5 terabyte is the maximum. If your dataset size is more than 5 terabyte, you should definitely move that to OLAP data stores. Again, 5 terabyte is also very, very huge. It should not be more than 1 or 2 terabytes in your OLTP systems. But in case of OLAP systems, the data size can be tens of terabytes or even petabytes. Because as the third point says that OLTP contains operational data and OLAP contains historical data. So if you are storing historical data, definitely the data size would grow over a period of time, and it can grow to tens of terabytes also. But as OLTP data stores are used for operational purposes, you should not let the databases grow beyond a certain point because it can impact the performance. So if your data size is going into terabytes, then you should think of a way to offload the data or archive the data to OLAP systems or maybe data lakes also. The query processing time in OLTP systems are very fast. Most of the times the response time is within milliseconds, if not seconds, but it does not go beyond seconds. But in OLAP systems, the query processing time is expected to be higher because data analysis is done here using historical data. So that's why it can be in minutes to hours also. And in OLTP, the data ingestion is done through applications, as I already told you at the beginning. And in OLAP, the data is ingested from OLTP sources or processing frameworks like Spark, Flink, etc. So as you can see, the purpose of OLTP databases and OLAP databases are very, very different. So because of that, the data modeling technique of OLTP databases and OLAP or data warehousing systems are also different. So in case of OLTP databases, there are some modeling techniques, and the main is ER diagram or entity relationship diagram. We can also use normalization, but normalization is used in OLAP also. Then in OLAP modeling technique, we have dimensional modeling, which is very different than ER diagram. There are other modeling techniques also in OLAP, but I'll be talking about dimensional modeling only in this particular chapter. And for OLTP modeling also, I'll be talking about ER diagram only. Before delving into data modeling concepts, let me introduce certain terminologies to you because these would be important going forward in both ER diagram and dimensional modeling. The very first terminology is entity or entities, which are nothing but business objects represented by tables. For example, we have customer tables and order table. So these are two different business entities. Customer is a business entity and order is also another business entity. So we create different tables for different business entities. Now the next term is attributes. So what are attributes? These are the features that define an entity. To give you a simpler definition, attributes are nothing but columns in a table, as simple as that. Now in business terminology, we call it as attributes, but in the technical term, we call it as columns in tables. For example, customer table has customer ID, customer name, address, date of birth, email and phone number. These are the attributes of customer entity, but actually these are columns of customer table. So if you see, the entity is directly getting mapped to a table and attributes are directly getting mapped to columns. Same is the case with order also. So the order entity has order ID, description, price, and so on. These are the attributes of order entity. But if you talk technically, the order table has these columns. So entity is the table and attributes are the columns. And then we have relationships, which are very, very important in relational databases. When you talk about data modeling, whatever data modeling technique I'm going to talk about, those are all related to relational databases only. We have relational databases in both OLTP and OLAP systems. We also have NoSQL databases, but only in the OLTP category. We do not have NoSQL databases in OLAP. Relationships are only for relational databases, and the concept is same for both OLTP and OLAP. So the first one is primary key, which is used to identify a single row uniquely in one table. For example, in customer table, customer ID is the primary key because customer ID would be unique across all the rows. We cannot use name as primary key because obviously we can have similar names across multiple rows. Let's say my name is Vikrant. There can be a lot of other people with the same name Vikrant. Or let's say the name is John. Definitely there are a lot of people with the name John. So we cannot use name as the primary key. That's why we use customer ID, because the system would generate unique customer ID across the board, across the entire organization. So customer ID would be unique, and so customer ID would be the primary key. Same is the case with other entity also. Here we have order ID. Order ID makes a particular order unique. So that is the primary key. So customer ID in case of customer table and order ID in case of order table are the primary keys. Then we have foreign key, and foreign key is used to define relationship between two or more tables. So let's say I want to find out the details of the customers who has placed a particular order. How do I find that? If you see in the order ID, we have order ID, order description, order price, the number of items, order date and customer. Now what is this customer? This is basically a customer ID because we do not have any other customer details. But if we have to find customer details, how do we find out for a particular order? So what we do, we get the customer ID from order table and use that customer ID in the customer table to get the customer details. There's a technical term, we call it foreign key. So using the customer ID, we can relate these two tables. So customer ID is the foreign key for order table. And customer table does not have any foreign key because we are not defining any other relationship. So now in this case, customer table becomes the parent table and order table becomes the child table. And we relate them using foreign key. So in this case, for order table, customer ID is the foreign key. And for customer table, customer ID is the primary key, and they are related using this foreign key terminology. So order is the child table, as I said, and customer is the parent table. Now let's talk about the data modeling process. How do we start and go about modeling our data? The first is we'll have to identify the entities. So if you have a data, if you have a business, you need to know what entities are there. So I have been talking about retail business. customers, orders, etc. So if you discuss about the business, you'll see orders is an entity, customer is an entity, product is another entity. So you'll have to define the entities or identify the entities and create tables for those entities. So each entity should be represented by a table. Then we have relationship between those tables or relationship between the entities. So how do we define relationship? Using the arrow mark that I had shown you, or using foreign key. Now relationship is also important because if you have to find a particular information which is not there in one table, how do you find that out? So use that relationship. In the previous slide, I had shown you that customer ID is used to relate orders table and customer table because customer information is not there in orders table. So use the customer ID in orders table to get the customer details from customer table, and that's how we relate two tables. So we'll have to identify all these relationships between the entities also. And then we'll use or identify the modeling technique. So should we use ER diagram or dimensional modeling or any other modeling technique for our data modeling process? For OLTP databases, it will always be ER diagrams. And for OLAP, we can use dimensional modeling. There are a lot of modeling techniques available in OLAP world, but we'll talk about dimensional modeling as I see. So that's about what data modeling is. Now to do data modeling, of course, we need to know certain concepts. So let's go ahead and talk about modeling concepts.